Welcome to The Explainer. Today, we're going to dive into some pretty brilliant engineering, a machine that harnesses the power of massive, slow-moving rivers. It's a fantastic story of innovation that really unlocked a whole new source of clean energy.
You know, when we think of hydropower, we usually picture these towering dams and huge, dramatic waterfalls. But this question gets at a totally different kind of challenge, one that needs a really unique solution for getting electricity from the sheer volume of water, not just how far it falls.
So let's get right into the heart of the problem. Because when it comes to hydropower, you'll learn pretty fast that not all rivers are created equal.
So early engineers, they had this big puzzle on their hands. Sites with a high head, and that's just a technical term for a big drop in height, well, those were pretty straightforward to deal with. But what about these enormous, powerful rivers that are just flowing through flat landscapes? That combination of super high water flow but a really low drop, that needed a whole new way of thinking.
Okay, so to crack this puzzle, we've got to understand the two basic ways you can get a turbine spinning with water. See, it's not just about making something turn, it's all about how you do it.
This breakdown of the physics is just perfect. Think of an impulse turbine like a quick punch. A high-speed jet of water smacks the turbine blades and forces them to move. But a reaction turbine, that's totally different. It's more like a steady, continuous push, using changes in water pressure all around its blades to create that rotational force.
And the key thing to get here is that a reaction turbine is completely submerged in the water. It works because as water flows over its specially shaped blades, it creates a difference in pressure. Honestly, it's a lot like how an airplane wing creates lift. And that principle is exactly what was needed for these low-head, high-flow river situations.
And this brings us to the big breakthrough, the moment that finally solved the low-head, high-flow problem and totally changed the game for hydropower.
So picture this. It's the early 20th century, and this Austrian inventor, a guy named Victor Kaplan, has an absolutely brilliant idea. He looks at something as common as a ship's propeller and thinks, what if I could make that work in reverse to capture energy from the water?
This quote right here just nails his key innovation. The secret sauce was one word: adjustability. See, Kaplan knew that for a turbine to be efficient in a real river where the flow is changing all the time, the machine itself had to be able to adapt. His design let both the wicket gates, which are basically just guide vanes, and the actual propeller blades automatically change their angle. I mean, you have to understand, this was a total game changer. It meant that these huge, massive rivers, not just sites with tall waterfalls, could now be tapped as powerful, reliable sources of electricity. It opened up countless new locations for clean energy all over the world.
Okay, so how does this thing actually work? Let's take a little journey. Let's follow a drop of water as it makes its way through a modern Kaplan turbine.
You'll see it's this incredibly choreographed four-step journey. Every single component is designed to control the water and just squeeze every last bit of energy out of it with maximum efficiency.
First things first, water enters the scroll casing. You can see it has this spiral shape that gets narrower and narrower, kind of like a snail's shell. It's a really clever design, like a funnel, that makes sure the water's pressure and speed stay perfectly consistent as it gets guided to the center. It just sets everything up for a nice, smooth flow. Next up are the guide vanes. You can almost think of these as the turbine's brain, or maybe like little traffic cops for water. They're adjustable gates that precisely control the angle and the amount of water hitting the blades. This is that first layer of adjustment that keeps the turbine working at peak efficiency. And now we get to the very heart of the machine, the runner blades. This is where the real magic happens. Just like those guide vanes, the pitch of these propeller blades can change on the fly. This dual adjustment system is the key. It means the turbine can maintain the perfect angle of attack to capture energy efficiently, even if the river's flow is constantly changing. And finally, after all its work is done, the water flows out through the draft tube. But this thing is way more than just an exhaust pipe. See how it gets wider? That shape slows the water down, and in doing so, it cleverly converts some of the leftover kinetic energy back into useful pressure. Not only does that boost efficiency, but it also prevents this really destructive thing called cavitation. That's when these tiny vapor bubbles form in low-pressure water and then violently collapse, acting like millions of tiny jackhammers that can literally eat away at the metal blades. So yeah, the draft tube is super important.
So, okay, we've seen all this incredible engineering, but what does it all mean in the real world? Let's look at why this super adaptable design has become so important for renewable energy.
Well, a huge reason for its lasting success is right here, its mind-blowing efficiency.
A well-designed Kaplan turbine can turn up to 90% of the water's available energy into electricity. I mean, that is just a phenomenal rate of return for any kind of energy system.
But, like with any advanced piece of engineering, there's no free lunch, right? It's got its trade-offs. That amazing performance and its unique ability to work where other turbines can't, well, that's balanced by some pretty high manufacturing costs and a vulnerability to that cavitation we talked about if it's not operated just right. It's a specialized tool for a very specific job.
And really, when you boil it all down, it comes back to its perfect niche. The Kaplan turbine is the undisputed champion for generating clean, reliable power from the exact kinds of water sources that other turbines just can't handle, the world's great high-flow rivers.
It's pretty amazing, isn't it? The Kaplan turbine is this incredible testament to how a brilliant, adaptable idea can last for over a century and continue to power our world. It kind of leaves you wondering, what elegant solutions are being designed right now that are going to define the next 100 years of clean energy?